So our next topic is abnormal molar mass and Van't Hoff factor. Abnormal molar mass and Van't Hoff factor. Van't Hoff factor. First of all, let's understand what is abnormal molar mass. Okay. So always remember, for ionic solute there are two types of conditions can be happen. First one is dissociation and second one is association. Like if you have a ionic solute like KCl, okay. Now we know that when we put this KCl salt in a liquid solvent, it will dissociate and forms K plus and Cl minus ion. So here what is happening? Dissociation. Dissociation. So here one particular particle is forming two particles, or one mole is forming two moles. Okay. So in the case of dissociation, the number of particles will increase, and if we consider this KCl as a one mole, and what is the mass of one mole? K potassium plus chlorine. Okay. So what is abnormal molar mass? How we can define the abnormal molar mass? So if we will find the molar mass of KCl. What is the molar mass of KCl? K is 29 plus 35.5, that is equal to 74.5. So this molar mass of KCl is for 1 mole. 1 mole. 1 mole KCl is equal to 74.5 before the dissociation. Now if you see, after the dissociation, the number of moles increases from 1 to 2. Here 2 moles are there, 1 mole for K plus and 1 mole for Cl minus. So from this side, after the dissociation, you can say that 2 mole mass is equal to K plus, that is 29 plus 35.5, that is 74.5. Okay. So here after dissociation, the mass for 2 mole is equal to this. So for 1 mole the mass will be the half of 74.5, that is 1427.25, 37.25 approximately. Okay. So this is the mass after the dissociation. So what you will see here, you will see that before the dissociation the mass was for 1 mole is 74.5, and after the dissociation the mass for 1 mole becomes 37.25. So this, the change in molar mass after dissociation, that is called abnormal molar mass. This is called the abnormal molar mass. And the number of particles are also changed. So what is Van't Hoff factor? So Van't Hoff factor is denoted by I, and Van't Hoff factor is equal to normal in terms of molar mass, normal molar mass upon abnormal molar mass, or I is equal to, so for this solution I will be, I is equal to, normal molar mass was 74.5 for 1 mole, abnormal molar mass was 37.25. So we will get the value of 2. So in this case, the Van't Hoff factor will be 2. Okay. One more formula you can write for Van't Hoff factor, that I is equal to number of particles after dissociation upon before dissociation. Number of solute particles dissociation after dissociation slash association upon number of solute particles same before after upon before association and dissociation. Okay, so this is how you can calculate the Van't Hoff factor. So Van't Hoff factor is actually a correction factor which corrects the value. As we know that the colligative properties are depend upon the number of solute particles. So whenever there is a dissociation, the solute particles will increase, and whenever there is a association, the solute particle will decrease. So what we do, we just multiply with Van't Hoff factor to correct the colligative value. Okay, so previously what we have learned in colligative properties, like first we have learned the relative lowering in vapor pressure. The formula was xv is equal to P naught A minus PA upon P naught A. Okay. This is colligative property which depends on the number of moles of solute particles. So to correct this value, we will multiply it with by I. So this Van't Hoff factor will correct the colligative value for the depression relative lowering. Again, the second formula for elevation in boiling point, that was del Tb is equal to Kb into m. So what we will do, we will multiply it by I. Again it will correct this value. M is what? Tells us about the number of mole of solute particles. So when we multiply that solute particles into I, so I will correct the number of particles of solute, and then we will get the correct value. Third colligative property was depression in freezing point del Tf. Again we will multiply it with I cross Kf cross. And fourth colligative property was osmotic pressure, that is pi is equal to I cross C into R. So Van't Hoff factor, that is I, is used for correcting the value in the case of association and dissociation. Okay, we have seen the case of dissociation. Now if there is a association, now what will be the value for I? Okay, let us consider we are having the 2 moles of acetic acid. When we put this acetic acid in benzene, it will get associated and forms one molecule of acetic acid, that is CH3COOH. Now here what is happening? Here the 2 particles of solute are get associated and forms a 1 particle, or 2 moles are converted into the 1 mole. Here again the value of I is equal to, after upon 4, after 1 particle is there and before 2 particle is there, so the value of I will be 1 by 2. So from this you can say, if in the there is a case of dissociation, the I will be greater than 1 in the case of dissociation, because the number of particles are increases. In the case of dissociation, the I will remain same if there is no dissociation or no association, that is in the case of non electrolytic solution. Non electrolytic solution or solute, and I will get less than 1 when there is a association in solute particles. So I will be greater than 1 when there is a dissociation, I will equal to 1 when there is no dissociation, no association, and I will less than 1 when there is a association. So this is how we can get the value of I. Okay, in the case of dissociation, okay, see, let us consider we are having a ionic solute A. When we put this ionic solute in the solvent, it will get dissociated and forms Na, means n number of particles. Okay. So let us consider at first the concentration of ionic solvent is 1. Before the dissociation, the value of dissociated particles will be 0 before the dissociation. Let us consider after some times alpha particles are dissociated from A. So it will form number of particles, that is n number of particles, so n alpha will be formed. Okay. So what we can write, what is alpha? Alpha is a degree of dissociation. Alpha is degree of dissociation. What will be the I? So I is equal to number of particles after upon before. So after number of particle or number of mole is 1 minus alpha plus n alpha, and before that is 1, and after the number of mole particle was this, and before 1 0, so 1. So the value of I will be equal to 1 minus alpha plus n plus alpha. You can write it like I is equal to, you can take alpha as a common, so 1 minus alpha n minus 1 minus n alpha plus n alpha minus alpha, like this. Okay, or you can write alpha is equal to I minus 1 upon 1 minus n minus 1 n minus. So this is the relation between the alpha and I. So this is the case of when there is a dissociation. Again, when there is association, let us